Emails, 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 emails. Whoa! What is going on here? Yow! What in the world is going on here? Whoa! Huh. Yeah! Man, what's wrong with this thing? It's the snap thing. I think the snap thing is broken. Courtney, I think my snap thing is broken. Snap thing's broken. Whoa! Courtney! Courtney!
What? Why are you wearing that?
What do you mean, why am I wearing this? The snapping thing, the geography J, the snapping thing, you're snapping.
What?
Whoa! Oh, good kitty. Hey gang, and welcome back to Geography with Jay. If you remember last week, Charlie asked us, what is a rock and why are there so many different colored rocks? The first thing we need to do is define a rock. A rock is a single mineral or many different minerals that come together to form a substance. There are three basic types of rocks. The first type of rock is igneous, which is a fire-formed rock. These rocks occur when lava and magma cool to form a rock. The second type of rock is what's known as a metamorphic rock. Metamorphic rocks actually are formed deep in the center of the Earth as a result of immense pressure and intense heating. Remember when we went to the center of the Earth last time? As I was going down through the mantle and into the outer core, there's a good chance I was coming across many different metamorphic rocks. The last type of rock is a sedimentary rock. The sedimentary rock is what happens when the other two rocks that we mentioned start to break down to small little pieces, and those little pieces come together, they squish real tight, and they become another rock entirely. That new kind of rock is what's known as a sedimentary rock. Okay, now that we've talked about the types of rocks, I think we got a question from Gavin about a specific kind of rock. Gavin, what do you got?
Hi, Mr. J. I have a special rock that has diamonds in it. It's called a Geo. Can you tell us more about it?
Hey Gavin, super cool rock. I love geodes. So geodes are a hard exterior with a crystalline structure on the inside. Now geodes can form in two types of rock, in both igneous rock, which is fire formed, or sedimentary rock, which is a bunch of small rocks squished together to form a new rock. Now how do these get formed? So the most important part of it is a hollow cave-like sort of cavity. So what ends up happening in an igneous rock is an igneous rock has lava on the inside that'll seep out of it, leaving a little hole. Well, that hole will have minerals move in there, and over hundreds of thousands of years, and sometimes millions, you'll form crystals, and those crystals form in the middle, and then that's a geode. Same thing with sedimentary rock. You'll see a branch that'll sort of dissolve away over the years, leaving a cavity, or maybe you'll see a more soluble or an easier to dissolve rock, and that'll leave that cavity. Minerals get in, and then you'll see crystals form over that same time period. So those are geodes. They're super cool. There's thousands and thousands of different kinds, and to keep on the lookout for them because they're lots of fun to look at. Thanks for the question. Keep them coming. Our next question comes from Liam in Colorado Springs. What can I do for you, buddy?
Hi, Mr. J. I live in Colorado.
Hold up. Did anybody just see what he was wearing? Okay, Liam. Now go ahead with your question.
Why do they call Denver the Mile High City?
Hey Liam, thanks for the question. Denver is known as the Mile High City because it is situated at 5,280 feet above sea level, which is exactly 1 mile. Or put another way, Denver's elevation is 2,885 Super Bowl trophies. That sounds about right to me. Alright Liam, thanks for the question, and go Broncos. Our next question comes from Christopher in San Diego. What can I do for you, Christopher?
Hello, Mr. J. Earth used to be one piece, now it's in several pieces. What will it look like millions of years from now?
Thanks for the question, Christopher. For those that don't know, what Christopher is referring to is a process called plate tectonics. If you look at the map now that we talked about from a few lessons ago with the continents, as you can see, all these continents are located thousands and thousands of miles away. Would you believe me if I told you that 200 million years ago, those continents used to be all squished together in one supercontinent called Pangea? That's pretty cool. I guess that begs the question, how did these continents that used to be all squished together to get broken up and spread apart so far? Well, the answer is plate tectonics. If you remember back to last lesson when we took that really cool journey to the center of the Earth, and we found that there was a super immense heating down in the inner and outer core. Well, that heating rises to the surface, a lot like you would see when you're boiling water when you see the bubbles come to the surface. The same thing happens in the center of the Earth. Do you guys remember last time when we talked about the oceanic and continental crust? Well, just below that is something called the plates. Now, the oceanic and continental plates are sitting on the surface of the Earth. And as the heat radiates and moves upward, it actually starts to push those plates away from each other. So Pangea actually broke apart because of that rising heat causing the plates to move away. Now those plates generally move about 10 to 40 millimeters every single year, which is about the same growth rate as our fingernails. Can you imagine what our fingernails would look like after 200 million years? Yeah, I hate that picture. Getting back to Christopher's question, what would the Earth look like after a couple million years? The answer is it really wouldn't change all that much. 2 million years, the Earth, those plates would move about 50 miles, so it really wouldn't change all that much. But if you took it over 200 million years, those plates would actually wrap all the way around the backside of the Earth, and they would actually smash back into each other, forming another supercontinent that I would probably end up calling Jagea. All right, Christopher, thanks for the question. As always, keep them coming. Okay, so our next question comes from Madeline in Stuttgart, Germany. What can I do for you, Madeline?
Mr. J, what are volcanoes made out of, and should I be afraid of them?
Hey Madeline, thanks for the question. Here's the thing though, you can't talk about volcanoes just sitting here on your buns. You gotta go see them yourself. So let's go take a trip to Ojo del Salado in Chile on the border between Chile and Argentina as the tallest volcano in the world at 22,615 feet. Let's fly. Bam. Yep. Boom. Aww.
Bing! You are now free to move about the cabin. Enjoy your flight.
All right, I made it. After 9 flight changes and 54 hours on the plane, I finally made it to Chile. First stop I get through to go to Ojo del Salado is the Atacama Desert. If you guys remember from our last lesson, it's one of the largest and driest deserts in the world and home to the Ojo del Desierto. All right, let's get to walking. I finally made it to Ojo del Desierto. It's beautiful in person. I love it. Man, okay, we made it. I got through the Atacama Desert and now I'm at the base of the Ojo del Salado, right? Now I gotta climb 22,615 feet to the top to find out what's in the center of this thing. But you guys know the drill. I can't go looking like this. All right, ready to go. Let's get climbing, come on. All right guys, we made it halfway. First thing I want to do is I want to describe what a volcano is. A volcano is an opening in the earth where liquid, gas, and magma can escape to the surface. Now, how did this particular volcano get formed? Well, if you look to the west of South America, there's an oceanic plate. Remember we talked about with Christopher? The oceanic plate bumped into the continental plate in South America, right? Like two brothers butting heads, right? The oceanic plate's more dense, so it went down below the continental plate. When it went down into the earth, it melted, the plate itself melted, and the magma rose to the surface and formed volcanoes all along the Andes Mountains. So cool, isn't it? Okay, now that we know a little bit about volcanoes, we gotta keep going, guys. All right, I think I see it. I think we're almost there. Oh, wow, that's what's on the inside of volcanoes. It's beautiful. All right guys, now that we did that, I'm addicted to volcanoes. We gotta go see some more. Let's get back on the plane and tour around the world. What do you say? Let's do it.
I know you from so far away. Another time, another place. As our lives intertwine, your fibers become mine, and now I am free as long as I'm with you.
Okay, Madeline, thanks for the question. Hopefully that answers a little bit about what volcanoes are. Now back to your original question of should I be afraid of them? Personally, I think that a lot of times we're afraid of stuff because we just don't understand them. Hopefully now that you understand them a little better, they're a little less scary. But what I will tell you is that there are a team of scientists all over the world that study volcanoes specifically. They're called volcanologists. And these guys do nothing other than making sure that we as people are safe in case there's ever an eruption. So if I were you, I wouldn't be afraid of them because there's a whole community of people, really smart people, just to take care of people like me and you. Okay, thanks for the question. Keep them coming. Our next question comes from James in Memphis, Tennessee. What can I do for you, James?
Mr. J, do all continents have volcanoes in them?
Hey James, perfect question for today's lesson. To answer your question, the answer is yes, there are volcanoes on each of the continents. Now, a lot like we did in the first lesson when we talked about the 7 summits, the highest mountains on each of the continents, now we're going to move through what's known as the volcanic 7 summits. These are the highest volcanoes in each of the continents. First, we have Ojo del Salado in Chile at 22,615 feet. Man, what a great adventure to go on this one. The second is in Africa, Mount Kilimanjaro, and this is in Tanzania at 19,340 feet. Next, in Asia, number 3, we have Damavand. This is in Iran at 18,603 feet. Next, we have Europe, number 4, Mount Elbrus, Russia, 18,510 feet. Following that, we have number 5, in North America, Pico de Orizaba. This is in Mexico, at 18,410 feet. Following that, we have number 6, in Australia, Mount Gilloway. This is located in Papua New Guinea, at 14,331 feet. Finally, we have number 7, in Antarctica, Mount Sidley, 13,717 feet. Alright James, that about wraps it up for the volcanoes on each of the continents. Now remember, if you're like me and you just love seeing these places, but you can't go yourself, you can always go in your imagination. If you got any more questions, keep them coming. For our next question, we return to Hawaii with Gage. What's on your mind, Gage?
Hi, Mr. J. My name's Gage, and I have a question for you. Why are the Hawaiian Islands sinking, and how long will it take for them to sink?
Hey Gage, how's it hanging, man? Thanks for asking your question. So why are the Hawaiian Islands disappearing, and how long is it going to take for them to disappear? So real quick, the islands themselves aren't sinking, they're actually eroding away. So there's a lot of things that are causing the Hawaiian Islands to get smaller. If you look at the map of Hawaii, you'll see on the bottom right-hand side of the map, or the most southeasterly side of the island chain, you'll see Hawaii. And then as you move to the northwest, you'll see that the islands start to get smaller and smaller. That's because those islands are actually the oldest, the ones in the northwestern side. So as they get older and older, they actually will get much smaller. The youngest island in Hawaii was made about 400,000 years ago, and the oldest one's being made over millions. So what's happening here, there's a lot of things that are causing it to actually shrink. First and foremost is the wave action. The waves constantly hit the islands, and one grain of sand is pulling a little bit of the island away. And then also you have the wind. The wind is causing a lot of the sand to get pulled off, and then it takes other rocks and smashes it into other rocks and makes them smaller and smaller, and causes those islands to get smaller. The last piece of it too is the rain. Now the rain actually comes down and starts to pull sand and rocks off of it and takes it into the ocean. The question of how long is it going to take, that's kind of a complicated question because there's one more thing that's causing islands to get smaller, and that's the sea rise due to climate change. So it's really hard to say exactly when that's going to happen. What I can tell you, it's going to be hundreds of thousands of years, so you'll be fine. Don't worry about it. No need to buy a bunch of floaties or life preservers just quite yet. All right, thanks for the question, and aloha. All right, guys, that's about all I got for this week's episode. Thanks for tuning in. What a fun time learning about rocks, volcanoes, islands, all sorts of cool stuff. And the best part about it, there's so much more we can learn. There's mountains, there's earthquakes, there's all sorts of fun stuff. So remember, if you've got a question, make sure you send it my way. If we don't get any questions, I'll have nothing to talk about, and that'd be like the worst thing. All right, guys, stay adventurous, stay curious. Thanks for tuning in. Bye.
I see you from across the